Good afternoon, everyone. I'm Anil Kumar from Toronto, Canada. Welcome to our class on advanced functions. I'd like you to introduce yourself one by one. Vishruta, can you please introduce yourself?
Hi, my name is Vishrutha. I'm doing advanced functions with Anil sir to be ahead of my class.
Hamza. Your audio is off, Hamza.
My name is Hamza. I'm going into grade 11 and I'm taking advanced functions to get a head start so I can stay ahead of my.
Akshay.
Hey, my name is Akshat. I'm doing advanced functions with Anil sir so that I can do my best next year in grade 12.
Right. So in a couple of weeks, we have done 5 units from the advanced functions book, which is followed in Ontario. We're working on rational functions today. So let me just share with you the lesson for the day. Can you all see my screen?
Yes, sir.
Great. Now, we did reciprocal functions earlier. In this particular case, after reciprocal functions, we look into rational functions. You know what rational functions are, right? Basically, rational functions are, let me write R of x as a rational function. They are ratio of two polynomials. So a polynomial in the numerator and a polynomial in the denominator. That is what a rational function is. And of course, the denominator is never equal to 0, correct? You cannot divide by 0. So that is what the rational function is. In today's lesson, we'll focus on the rational function of the type ax plus b divided by cx plus d, right? So that's the type of rational function which we are getting into today. Basically, it is the ratio of two linear equations, correct? So we have ax plus b divided by cx plus d. We'll look into the characteristics of this type of rational function today. If you sketch a graph of this function, it will look like the graph shown here. And as you can see, this particular graph has two asymptotes. So maximum, it could have two asymptotes. So there will be a horizontal asymptote as shown here. So in this case, the equation of the horizontal asymptote could be what? Can any one of you tell me? What is the equation of this horizontal asymptote shown here?
Y equals to minus 3, sir.
It's a horizontal line, y equals to minus 3, correct. And how about the vertical asymptote?
I think it's also y minus 3.
X equals to 3.
X equals to minus 3.
So the vertical line is basically x equals to a constant value, right? So every point on this line has the same x value. That's the concept, correct? The horizontal line, the y value is constant. It is minus 3 in this particular case. So these are the two asymptotes. So when you talk about rational functions, asymptotes is a new thing which you're going to learn. We'll look into how do we find equation of asymptotes from the given equation. And also, we'll do the reverse thing. Perfect. So the things which we are going to cover today is to understand how do we find x-intercept, y-intercept, vertical asymptote, horizontal asymptote, domain and range, sketch graph, equation from the graph, and applications, correct? Now, do you understand what is an asymptote? Can you define what is an horizontal asymptote? Any one of you?
So an asymptote is basically a line that will keep on going and going, but will never touch a given. Like for example, if you had an asymptote on 0, it would never touch 0, but it just keep going and going and going. It keep like getting gradually closer and closer, but
You're
never.
kind of close to the definition, but not exact. So anybody else?
Isn't an asymptote like a line where the function, it approaches the asymptote, but it never actually
Function approaches the asymptote, right? But there's another very important component. As x approaches positive infinity, what does y approaches? If y approaches a value, let's say L, in that case, the horizontal asymptote will be y equals to L. Do you understand? So when x approaches a very large value, in that case, what happens to the function? What is the end behavior? So horizontal asymptote actually gives you end behavior of a function. Is it okay? Now, we could go the other way also. When x approaches minus infinity, then what happens to y? If it approaches a fixed value, then we have another horizontal asymptote. So basically, rational functions could have two horizontal asymptotes. One, when x is approaching the negative infinity, the other, when x is approaching the positive infinity. The horizontal asymptote is only defined when x is infinitely large. What is happening to the value of y? Do you get this idea? So there is a possibility of having two horizontal asymptotes, correct? Many times students think, no, one horizontal, no. Well, there are cases where there may not be any horizontal asymptote. We'll look into those cases later. But if you have an equation of the type shown here, ax plus b over cx plus d, it will always have one horizontal asymptote. Is it okay? When we will explore rational functions in more details, different types of functions, we'll come across many examples where there will be two horizontal asymptotes. There may not be any horizontal asymptotes. We will also see that the curve actually crosses the horizontal asymptotes also in between. Since horizontal asymptote is only defined at infinitely large values. In between, the function graph could be anything. You get the idea. I could have a graph of the function which could be, let me just sketch one here, which could actually, not in this case, okay, we'll see, let's say which may go like this. Do you understand? Which may cross the horizontal asymptote in between and then approach. You get the idea, like this. It is possible. So don't think that the curve cannot cross horizontal asymptote. Is that clear to you? That is to say that the range normally will not include the horizontal asymptote value, which is y equals to -3 in this case. But there are cases when that y value may be included as the curve may cross. Very important point, okay? Right. Now, we are focusing today on this particular type of a rational function, which is ratio or quotient, we say sometimes, of two linear equations, correct? Then the type of graph which you will normally expect is these kinds, basically a reciprocal function, right? 1 over x, correct? With different values of horizontal and vertical asymptotes. So basic characteristic will be as one of these shown here. You get the idea. Is that okay? Now let's explore this in further details. So let me talk about how do we find x-intercept. Now, can you tell me what is an x-intercept, Akshat?
Sir, an x-intercept is a point where the curve touches the x-axis and the y value is 0.
Correct. F of x, the y value is 0. So when f of x is 0, substitute 0 for f of x, correct? Solve your equation. Well, this is 0 only if the numerator is 0, correct? 0 divided by anything is 0. Therefore, ax plus b should be equal to 0. You can isolate x, taking b on the other side as minus b dividing by a. So you get x value as minus b by a. So the x-intercept value will always be minus b by a. You get the idea? To give you an example, if my rational function is x minus 6 over 2x plus 3, what is going to be the x-intercept? Minus of b value, which is minus of minus 6, right? So which is 6 here over a value, which is 1. Do you see that? Is that clear to you? Obviously,
Sure.
Yes.
So the x-intercept would be 6 over there in that case?
6. Yeah, will be 6. Basically, the numerator should be 0, correct, for x-intercept? So you can equate x minus 6 equal to 0. What do you get? You hit x equals to 6. You get the idea. In this case, what is going to be the x-intercept? Hamza, can you tell me x-intercept? Solve for 0, right?
Minus 2.
3, correct? Now, Vishruta, can you tell me the x-intercept for this equation?
3.
3 is minus 3. So 9 over 3 will be giving you minus 3. You see how easy it is now? Any rational function of the form ax plus b divided by cx plus d will always have x-intercept at minus b by a, correct? Basically, we are equating the numerator to 0 to get x-intercept. Is that clear to you? Absolutely clear. Now, let us see how do we get the y-intercept. Well, as you know, y-intercept is substitute x equals to 0, correct? Y-intercept on the y-axis, x is 0. Substitute x is 0, they become 0, right? What do you get? B over D, correct? So basically, you're trying to find what is f of 0. F of 0 is the y-intercept. So y-intercept is always B over D, yes.
So if we use the concept B over D, right, for the first one, x minus 6 over 2x plus 3, would the y-intercept be minus 2?
Yes.
Okay.
Simple as
So
that.
okay.
Yes, yes. So this ratio is your y-intercept. Is that clear to you? So this ratio is the y-intercept, and the earlier ratio, I mean, equate to 0, gives you the x-intercept. You get the concept. Here is an example. So in the example, we have f of x equals to 2x plus 3. To find the x-intercept, what am I going to do? I'm going to equate the numerator to 0, right?
Sorry, I have
And
a
I'll get
question.
minus 9 over 2, which is the formula. But you could solve it, or which is, you can say, well, it is 2x plus 9 equals to 0, which implies that x is equals to minus 9 over 2. Is that clear to you?
I have a question.
Yes.
So when you were finding the x-intercept, why did you only equate the numerator and not the denominator?
Y value is 0. How do you get y value as 0? If
No,
you have f of
I thought like
x,
if it was like a
as
full, it was like a whole function, then when you
if f
evaluate
of
the
x
whole
is
thing,
p of x over q of x, what is the x-intercept? Where f of x is 0, right? When will it be 0? When the numerator is 0, p of x is 0. You get the idea. So in general, any new numerator that has to be equated to 0 to find all the x-intercepts. Is that clear? In our
so
case,
every time you're finding, so regardless of a function, every time you're finding the x-intercept, you always have to set the numerator as 0.
correct.
And then for the y-intercept, is it? I think
Always
it's
x equals to 0. Yes, obviously. Correct.
okay.
Correct. That is same.
Sure.
That is why it is very important to understand functions by functions, right? Yes, Akshay.
Sir, so this y-intercept and x-intercept concept only works for a rational function in the form ax plus
All
b over c
functions.
plus d, right?
All functions.
Oh, all
General
functions?
function.
Okay. Okay. Okay.
It is a general concept, okay? Yes.
Okay, sir.
But we have this formula which is only applied to this case. You understand? Correct? It will
So
help
this
you
is
in
what I
reverse
wanted to ask.
calculation.
That for the second one, why did you make the a is equal to 0 and then the c equal to, you made the numerator and denominator equal to 0, right? Or
No, the second one I substituted 0 for x. So 0
okay.
times anything is 0, right?
Oh yeah, okay, okay.
I substitute 0 for x. So 0 times anything is 0. You're left with b over d, correct? Is
And then
that
did you do the same thing for the third one too?
third
0.
one? This is an example.
Uh-huh.
So you are given this function, you need to find x and y intercepts, put numerator equals to 0 to find the x-intercept, and put x equals to 0 to find the value of y-intercept. Is that clear to you?
Yeah.
Basic concept. Go with basic concept. I'm not saying remember the formula, but I'm just showing you that these results could help you later. I'll tell you how. If I tell you that you have to give me a rational function which has an x-intercept of 2 over 3 and y-intercept of 5, this can help you to give you the values a, b, c, d. You get the idea. You can get those values, correct? More to come. Don't worry, don't worry, don't worry. So we have seen x and y-intercept. Now let's look into vertical asymptotes and the horizontal asymptotes. Vertical asymptote. When do you get a vertical asymptote? When the denominator is 0, correct? We have a restriction. So basically, vertical asymptote is when denominator is 0, denominator is cx plus d. Equate that to 0. What do you get the value of x as? Minus d over c. Just solve for it. So if I have this equation 2x plus 9 over x plus 3, then where will it have the vertical asymptote? You have to equate x plus 3 to 0, correct? So when you say x plus 3 equals to 0, x is equals to minus 3, that is your vertical asymptote. Is this clear to you? Simple as that. Any of these functions, you can say, well, what is the vertical asymptote for this case? Vishruta, can you tell me what is the vertical asymptote for f of x, 3x minus 2 over 2x? When is the denominator 0? When x is 0.
is equal-
And in this case, where is the vertical asymptote? Yes, Hamza.
5. 5
5. And this place x equals to minus 3 over 2, correct?
2.
So we got the vertical asymptote easily just by putting denominator to 0. Is this clear to everyone? Simple as that. Basically, we are going in such a simple way to understand this function so that you don't have any difficulty in times to come. Now let's look into the horizontal asymptote. It is slightly difficult concept. What did we say? Horizontal asymptote means when x approaches positive infinity or negative infinity, if y value approaches a fixed value L, then we have a horizontal asymptote whose equation will be y equals to L, correct? So what are we going to do? We are going to check the value of the function when x is very, very large. And here is a good technique to do it. I like your attention to understand the technique. We have ax plus b divided by cx plus d. I'm taking x common in the numerator. When I take x common, what do I get? A plus b divided by x, correct? Is this clear to you? So we have ax plus b. I'm factoring out x. Then what do I get? A is left here and b divided by x is left there, correct? Is this step clear to you?
Yes, sir.
Vishruta, is it clear? Hamza, is it clear to you? Very important step. And that is what I did for denominator also. I took x common, I get c plus d over x, correct? Now I can cancel the x. What do I get? A plus b over x, c plus d over x, correct?
Sir, I have an easier way to do this. Can I just share my screen for like
No,
1
no,
second?
don't share.
Okay, I'll share it at the end.
Understand this way. No easy way.
Okay.
Forget. If you think that's a good way, keep using it, but don't share with me.
Okay.
Yes, after some time you will realize why I am saying, okay. There are so many ways to do a question, right? I'm telling you the best way. Now x and x cancel, you're left with a plus b over x divided by c plus d over x. Now the question is, x approaches a large value. So if x is approaching infinitely large value, then what will happen to b over x? Tell me. Akshay, what will happen to b over x when x is very
You'll
large?
approach 0, sir.
It will approach 0. So these two terms approach to 0. So we get the ratio a over c, correct? Because these two terms approach to 0. So the asymptote value is a over c, correct? So here we have a very good formula to use, that the horizontal asymptote will be a over c. We'll write this as horizontal asymptote as y equals to a over c, correct? Instead of f of x, I'll write y equals to a over c is the horizontal asymptote. Is this clear to you? So my formula is y equals to a over c for horizontal asymptote. So it is the ratio of the leading coefficient here. You get the idea. So when you have a rational function of the type ax plus b divided by cx plus d, in that case, the horizontal asymptote is a over c. Absolutely simple. There cannot be anything simpler than that. And the concept which I have shared with you belongs to the calculus part. So you will learn more about it in calculus when we talk about limits. But this is the approach which we are going to adopt in calculus. And that is why I'm teaching you this approach today, correct? We are not going with any other shortcuts. They're only confusing your minds. Okay, let's be very clear about it.
Sir?
Yes.
Just a small clarification. So when x approaches an infinitely large value, right?
Yeah.
We said y approaches L, right, sir? So that L represents a small number, right?
Any value. No, it could be any value, but not
Okay.
infinite. Any value, any real number. So L belongs to real numbers. Is that okay?
Okay.
Any real number. It doesn't matter 1,000, 5,000. It depends on equation, correct?
Right.
So that is important. Now, quickly, tell me one by one. What is the horizontal asymptote Akshay for f of x equals to x minus 6 divided by 2x plus 3?
Sir, for this one, I think it'd be a over c, right? So
Yeah, it will be this ratio, right? So how much?
1 over 2.
Hamza, can you tell me the horizontal asymptote for the second equation? 3x plus 9 over x minus 5.
3.
Such easy. How about this? Vishruta, tell me the equation of x horizontal asymptote. 3/2, correct? Just the ratio of the coefficients for x. Is that clear to you, everyone? So simple. You don't have to think about it. So you don't have to show these steps, but these steps are important for you to understand. Okay?
Wait,
Now-
sir.
Yeah.
Well, I think I would just want to ask, what if the degrees are different for the?
No, we are talking about a rational function of the type ax plus b over cx plus d. Is that okay?
Oh, okay.
Yeah. We are not talking about any other rational function today.
Okay. Okay.
Yeah.
Makes sense.
So yes. So let
Mhm.
us be focused on what we are talking about. Perfect. Yes. So now, if you have a rational function of the type ax plus b over cx plus d, in that case, you have understood what could be the x-intercept, what could be the y-intercept, what could be the horizontal asymptote, what could be the vertical asymptote. Is that clear to you? Once you know these things, you can sketch any function of this type, correct? Good. So now we have some examples for us. Okay, before that, some domain and range. Now, when the function is of this type, always remember, we are only talking about ax plus b over cx plus d type of function. Let us not get confused ourselves with, right? The domain is, of course, you cannot have the vertical asymptote in your domain, right? So the denominator cannot be 0. So domain is all x values except for minus d over c, correct? Clear? And the range is that you cannot have the horizontal asymptote because in this case, the curve cannot cross the horizontal asymptote. And therefore, the range is all the real values except for the horizontal asymptote y value, which is a over c. Is this clear to you? Which is this ratio. Is that clear to you? So that becomes the range. So now, if I have an example of the type f of x equals to 2x plus 9 over x plus 3. So Hamza, can you tell me what is the domain of this function?
So the domain would be 3
X belongs to real number, but not minus 3. The denominator cannot
minus
be 0.
3. Yes.
You mix up with signs always.
Yes. Sorry. I was just basically it's just making the x equal to 0 and then you find.
Denominator equals to 0. Just write x plus 3 equals to 0, which is not possible, correct?
Yeah.
So x is not equal to minus 3. That is what will come here. Is this clear to you?
Yes, 100%.
As far as the range is concerned, tell me, what is going to be the range of this particular function?
The range would be 2, not equal to 2. X,
Not
y,
equal
or
to
the numbers
2,
y
which
is not
is
equal.
this ratio of horizontal asymptote. Perfectly fine. Is that clear to everyone?
Yes.
Perfect. So this could be your practice question. I've just taken these along with us as we are discussing so that you can quickly get into their solutions, right? X not equal to minus 3/2, x not equal to 5, x not equal to 0. Clear. Y not equal to half, y not equal to 3, y not equal to 3/2. Done. You see that domain range we are done with these equations. Any of this kind? Yes, please.
Sir, so it's a good idea to memorize these formulas, right?
You
Because-
will remember, don't worry.
Yeah.
It is basic concept, right? One thing, when we are saying restriction in domain, which means you cannot divide by 0. So definitely I will put this not equal to 0 and get my thing, correct?
Yeah.
The thing is, when you do these things so many times for a particular function, because this is a chapter with you, this is a chapter, do you understand? There is at least one question from this chapter which is going to come. If you start working from top to bottom, you will spend 10 minutes. Otherwise, you can do it in 2 minutes. You will save 8 minutes for another question. Do you understand the idea? You have to master these techniques. Save time, move on. The question will be, sketch this function, right? You write 5 points, x-intercept, y-intercept, vertical asymptote, horizontal asymptote, right? Domain, range, here's my function. Because you know, this is my horizontal asymptote, this is my vertical asymptote, that's the graph. I'm done. You get the idea. So if you understand the way I'm teaching you, you are going to save such a valuable time. This has to be a very simple question. Yeah.
Sir, this is a little like off track, sir, but
No
if we
problem.
were to graph the function 3x minus 2 over 2x, right?
Yeah, yeah.
We would start with the x.
Yeah, we will do
intercepts,
that
right?
also. Don't worry, we'll do that. Don't worry.
Okay, sir. Okay.
We have all the parameters, x, y intercepts, correct? Plot those 2 points, horizontal, vertical asymptote, plot those 2 points. Just
Yeah.
take some values, 1 or 2, to get accuracy. Is that clear to you?
Okay.
Don't worry, here is your graph. So now the question is, we will do the reverse. Find the equation of the graph of a rational function. So I'm not sketching. Sketching is very simple. You want to sketch, we can go for sketching also. But now, okay, let's go for sketching first. No worries. Which function do you want to sketch? Akshay, tell me. Out of these
Sir, we can pick any. Since we were talking about the third one, we'll do 3x minus 2 over 2x.
Okay, third one. So first thing first, draw your coordinate axis right. Then what is this? It gives me the restriction, the vertical asymptote. So the vertical asymptote for this graph is at x equals to 0, right? So just draw a dotted line here, correct? And write down that this is a vertical asymptote which has x equals to 0. That is your 1 point. Is that clear? Horizontal asymptote, 3 over 2. So 1.5, 3 over 2, right? So you say, write this. You say vertical horizontal asymptote, which is y equals to 3 over 2. Do you see the second point? If this is a
Yes, sir.
5-point question, you already have got at least 0.5, if not 1. Okay. Now we are looking into x and y intercepts. Obviously, we cannot have any y-intercept, right? So no y-intercept. No y-intercept, because we have the vertical asymptote, but we have x-intercept. X-intercept means numerator is 0. Numerator is 0 when 2 over 3, right? So this point is 1.5. So 2 over 3 is less than 1.5. So somewhere here, correct? Sorry. Oh, sorry. I got
On the x-axis, right?
on the x-axis, 2 over 3. Yeah. So here, these are my intercepts. And so therefore, the graph will be approaching these. And so I have my graph. Do you see this graph now? Done. You could check if it is x. Find f of -1, correct? And find f of 1. Is that okay? And put those 2 points there. Is that clear to you?
Yes, sir.
Do you understand how easily we have got this whole thing?
Yes, sir. Because if this
Any
is
problem?
sketched, then we can do
Any
it really
problem in
quickly.
this? No problems. This has to be a simple question in the test paper, and you cannot afford to spend more than 2 or 3 minutes on this question. If you do, then you have lost the last question for sure, because your paper is going to be very lengthy. Let's be clear about it, okay? It is grade 12 functions, advanced functions, right? You will have so many questions that you cannot afford to waste time on any question. So sketching is simplest thing here to do, correct? Yes, so practice some more. Now let's look into this part. Hamza, I want to find the equation of this curve, which has a vertical and horizontal asymptote. Can you tell me, how will you proceed?
So first thing I would do is I try to identify the asymptotes
Okay,
on this graph.
tell me.
So
vertical asymptote.
if I'm not wrong, the first asymptote, the vertical asymptote is at x equals to 3,
Yeah,
and the horizontal asymptote is at I think that's also 3. I'm not really
minus
sure.
3. Yeah.
Minus
That's
3.
slightly small. Let me just increase the. Yeah, that's okay, right? Perfect.
Mhm.
Minus 3. So you got 2 asymptotes, right? Now, okay, and x-intercept and y-intercept.
Yeah. So your x-intercept would be at, I think that is 2.
2, right? So let me write 2, 0. Is it okay?
Yeah.
And y-intercept?
Y-intercept is at,
Minus
let's see, -2. Okay.
Is that clear?
Yeah.
Now these values are given. Tell me, what is ABCD? What is ABCD in AX?
The way I was thinking
Yeah.
was that, so the horizontal asymptote is a ratio of A and C, right?
Correct.
So you can make A and C as like 3 and 1. I think that would work.
-3.
-3 and 1.
1 means C is 1, right? Okay, so you write X here. Correct. Now vertical asymptote is X.
Okay, so vertical asymptote has to equal to, when you sub in a value, it has to, okay, yeah. So
Do you see
so
that?
that's equal to
Minus
-3.
X minus, is that clear to you?
Yes.
Now, x-intercept is, or you can say y-intercept is this, right? If I plug in 0 here, I should get -2, correct? So what I'm saying is, if I put 0 here, I should get -2. So -2, is that okay?
Yeah.
I plug in 0, I get -2. But now, you have to check what is x-intercept. How will you check x-intercept? When is this equal to 0?
Okay.
How will you have to check what is x-intercept, right?
Yeah.
X-intercept is
When you so when you plug in x into negative 3x, right? So that's how you find the x-intercept.
f of x is 0, right? You have to,
Yes.
but you do not get that value. You see that?
Mhm.
You do not get 0 when I put x equals to 2, right?
Sir,
Yes.
if we change the -2 to 6, would that work?
So the idea here is, because what we have to do here is, since we did not get the x-intercept, we did get everything else, right? You have to check all the values. So that means there was a factor outside. You get the idea? There was a factor outside. So we have to double this up. Do you get the idea?
Yeah.
We have to, because x-intercept is at 2. So that has to be 0 at 2. That is only possible if this value is 6.
Sir, so for these type of questions where we find the equation, right? Do we have to work backwards? Like from
we have to work backwards. So, and that too, now let's say it is -6, it has to be +6. So we have to take a minus outside. You get the idea?
Okay, so you factored the negative, right?
-3. Do you understand it? Shall we go over it again? Let's go over it again. Okay, Akshat, you tried this time.
Okay, sir.
From where do you want to start?
Sir, so when you and Hamza were doing it, right? So I was looking at my notes and I noticed that they x-intercept, y-intercept all have like common variables in them, right?
Yes.
So for example, if we start with the x-intercept, then minus b over a, right?
Yes,
so,
minus b.
Yeah, so then the b has to equal to the y-intercept b2, right?
Yes, yes.
So if we work at it like that, then
it is easier.
Yeah.
You get the idea. So that is why when I began the lesson, so I looked into these topics. Do you understand now why I went into that?
Yes,
general equation, general solution. So each general equation will give me the value of x and y-intercept. Do you understand? And now we will be able to solve a question like we have right here. So one way is, if the question is simple, you understand. The problem here is that we have -3 outside and the equation is x plus 2. You see this? You get the idea? So the question which is given to you has a factor outside. Therefore, the simple technique which I was trying with Hamza failed. Hamza, you get the idea? If I have to give a test question, I will give this test question where there will be a common factor and teacher will never explain you this. And you'll be working with those numbers and getting this answer, not this value.
But I mean, I know like it's a common mistake, but if we were to like just check it, we probably would just find an error.
Time, Hamza.
Yeah.
If you spend extra time on this question, mark my words, I have to share with you the test papers of advanced functions. They are calculated till the tip. If it is 1 hour test question, you cannot leave your pen idle for 5 minutes. If you leave it, you will lose the last question, mark my words. And we are talking about grade 12. We want you to get more than 95% marks. If you lose one question, you are out of that competition. You cannot get admission in Waterloo. Forget about it. Let's be clear about it. Let's be real. If you want admission in Toronto University or Waterloo or somewhere like this, no, man, you have to work as I'm telling you very strategically, every minute is precious. Akshay, are you understanding this concept?
Yes, sir.
Yes. Now you learned one more technique here. That is, you could go like this standard way, means, right? Keeping in mind that there could be a common factor. Like in this particular case, -3 is my common factor. Okay. And that is how a good question will be given to you in the test to find equation from the graph. This is one of the most difficult questions I've picked up from the previous test paper. You get the idea. All my questions are from previous test papers. I know my students failed. They could not give this value. They wasted time. Only those who went with A, B, C, D, they got the right answer in first shot. Okay? So that concept which I have spent time with you was an important concept, specifically targeted to get you the solution of the last question which we dealt with. Is that clear? Okay. Hamza, I'd like you to read this question, please.
Cost of production of X robots in a week is given by C of X equals to 20,000 plus 800X. How many cars would be produced in a week to maintain average production cost A of X to be $12,000 cars per week per car?
So how will you do this question? Average, when it comes to, you understand the meaning of average, right? Average is divided by the total number, right? So here it is X, correct? So C of X equals to 20,000 plus 800X. You want to find the average cost, divide by 1200 X. The average cost is 1200, divide this whole function by, so 1200 is the average cost, so which will be equal to C of X divided by X. You understand? So if you put, yes.
So can you repeat that?
This is the total cost, right?
Yeah, C of X.
So divide by X, you get average cost.
Okay, so
just divide this equation by X, equated 1200, and you get your answer. Is that clear to you?
Oh, okay. Yeah.
So it becomes a rational function, linear over linear. The one which we are talking about, it's an application question based on what we are learning. Clear?
So, sir,
are you getting it? Whenever average word comes, it is rational function, this particular unit. Okay, time and work application. Akshay, please read this question.
Anu can complete the job in 5 hours less than Ben. Together, they will complete the job in 6 hours. How long will it take Ben to complete the job? Okay.
Your homework. Now, whenever it is a rate question, time and rate, it is again a rational function. If I am doing a job faster, I will do more job in the given time, correct?
Yeah.
Reciprocal function, correct? Inversely proportional. Rate is like speed. If you run fast, then the 100 meters will be covered in shorter time, correct? So that is the whole concept again. So basically we are saying Anil can complete a job in 5 hours less than Ben. If Ben takes B hours, Anil take B minus 5 hours, correct?
Yeah.
Together they can complete the job in 6 hours. Total time is 6 hours. In 6 hours, how much of the whole job will be done by Anil and how much of the whole job will be done by Ben? 1 over B plus 1 over B minus 5. You get the idea. Reciprocal. You get the idea. And in 1 hour, we will do only 1/6 of the job. In 6 hours, we complete the whole job, correct? In 1 hour, 1/6 will be done. But in 1 hour, because the speed of Ben is B, he will do 1 over B. Another speed is B minus 5. He will do 1 over B minus 5, which is more job, which will be equal to 1 over 6. Do you see how easily we got a rational function to solve? Hamza, do you understand this? Vishruta, do you understand this? Very important, very difficult equation to derive, but now you understand. Rate. We have to see what is the work done in 1 hour. 1 hour, right? So if in 6 hours I will do the whole job in 1 hour, 1/6, 1 over 6, correct? Right hand side. If Anil is doing job in B hours, then in 1 hour, 1 over B. 1 over B minus 5, you get the idea, reciprocal. And equate the two. Because they together can do the job in 6 hours. So together, each person just check in 1 hour how much are they doing. Correct? You get your equation. Solve this.
Yes,
Get your
that's
answer.
sorry, that's what I was thinking. It's like if you were to just do it like just the way it starts, Ben, you could make Ben equal to B and then
Yeah. Yeah.
know
This is your first step.
That's the first step.
And then you write down the rate, right? Rate is 1 over B plus 1 over B minus 5, and it goes to 1 over 6. Done. 1 hour job. Or you can say in 1 hour, how much work are they doing together? In 1 hour.
So now
how
you
much
solve for
work-
Ben, right?
Huh?
Now you solve for Ben.
Yeah,
How long
you
will
can
it
solve
take
for
Ben?
Ben. Yeah. How long will it take Ben to complete the job? They could have asked Anil also. Then you do B minus 5.
B minus 5. Yeah.
Yeah. But anyway, you understood the
I
question.
have a question. Why did
Yes.
you do the 1 over B plus 1 over B equals 1 over 6? How did you do that? Oh, okay, I get it now.
1
Because
over
both
B
of them
minus
together.
5. Anil is doing faster, right? So 1 over B minus 5. Is it okay?
Yeah, I just want to ask about the 1 over B. How did you get that?
Rate. In one, okay.
Oh, I think I get it.
Rate. Let's look like this. This is my job. Like job is painting one wall. Let us say painting one wall is one job. Is it okay? The job is completed by me, Anil and Ben, in 6 hours. In 1 hour, how much wall will be painted? 1/6, right? To paint the whole wall, we are taking 6 hours. In 1 hour, we will do 1/6 of it.
Mhm.
And that 1/6 of the job, out of that, how much will Ben do? Ben's speed is B. He will do 1 over B. Anil's speed is B minus 5. Anil will do 1 over B minus 5. We'll add these two guys equal to 1 over 6. Get our equation. You get the idea now?
Yes.
Sir,
Yes.
it's a reciprocal function because we're considering the time for 1 hour, right?
Yes.
1 over B and 1 over B
But when
minus
you
5.
make an equation, it becomes, it's kind of reciprocal indeed, right? And then you cross multiply. Do you see that?
B minus 5 plus B, right?
Plus B equals to 1 over 6. Then you cross multiply. See, solving is not difficult. Getting the
Right.
equation is difficult. Okay. What do I have? Do I have something else? Oh, we have the solutions. Oh, very good. I don't want to share the solution with you. But anyway, you have understood the concept, right? The average cost is C over X. Just divide, equate it to 1200, get your answer. We're not looking into the solution. Is that okay? So 1 over X minus 5, 1 over X equals to 1 over 6. Now, important thing is, we have a restriction. Let's see that. The time cannot be negative, correct? The job cannot be negative. Therefore, X minus 5 has to be positive. So X is greater than 5. Do you understand the restriction?
Sir,
X
so that
is
would be one of
greater
your
than-
asymptotes too, right? In
Yes.
the function?
Yeah, 5, but it has to be positive, correct?
Right.
We are talking about some work done. We are talking about time. In this case, it has to be positive. So that is the restriction. X has to be greater than 5. Sometimes when you solve, for example, here, you get two values, correct? One of the values is 2, right? I've shown the solution here. One of the values X equals to 2, correct? But that is redundant, not valid, because X has to be greater than 5. Is that clear to you? So when you solve, remember that you have to look into restrictions. So when you write down your equation, immediately write down the restriction so that you may not select the wrong answer. You could select wrong answer. If you select X equals to 2, then Anil will be what? 2 minus 5 means minus 3. Oh, how is it possible? He has to take some time to do the job. It cannot be negative, correct? So it is 15 hours. Okay, enough. Very good. We're done all this. Okay. Did you understand the chapter? Is this absolutely clear to all of you?
Yes, sir.
So reciprocal function, one question done. This is the second chapter, AX2 linear, quotients of linear function. We've done that. Another question from your rational functions unit test. Very important questions. Plus, We have also seen an application question in this particular example, which belongs to rational function. So 3 questions we have done from this particular unit. Do you get the idea? Actually 3 questions, which will come in your test paper. Okay. So we are going to stop sharing the screen. And I'd like you to share with me today's learnings. Okay. Hamza, what did you learn today?
So I basically learned, I have obviously emailed you the other day, but I kind of just learned about just the finding the horizontal and the vertical asymptotes. Those are kind of very crucial, and just how you can relate that to finding the domain and range.
Correct.
I think that was really crucial. And then also graphing too. That was
Very. How about you, Vishruta?
I've seen rational functions and stuff in like test papers from the SIRD class, and I was always curious about them. And now I learned like all like the tips and tricks, and even the application questions, the homework question that you gave, and even the graphing was really helpful.
Very. Akshay.
Sir, so today's lecture was a pretty heavy lecture because I learned a lot from it, right? So what I found most useful is, as usual, the way you teach us how to like solve questions really fast, right? Because as we can see, these questions are not easy, right? So the techniques that you taught us with like the domain and range, relating the variables and everything, I think I need more practice, but definitely I can solve the questions much faster.
Correct. So look into my playlist on rational functions. Just type in Anil Kumar rational functions playlist. You will get so many previous test questions solved. Practice from there. That will help you. Okay. So we'll end our lesson here for today. Have a good day. Bye and all the best.
Bye. Thank you, sir.
Thank you. My pleasure.